What is our world made of? To answer this question, humans built a particle collider with a circumference of 27 kilometers. Accelerate particles to close to the speed of light, then let them collide. Result, scientists. I found something that sent shivers down my spine. Constitutes you, me, and the most basic matter of the whole universe. It may not be a substance at all. They have no size. There is no shape. Not even any physical features you can imagine. More like some kind of ghost or ripples on the water. This is not science fiction. It is the truest science. And it took more than 100 years for humans, using the smartest brains in the world, and the most expensive equipment. Only then can I barely understand a little bit of science. Let's talk about it today. This excites physicists. The ultimate question of madness. What exactly is our world made of? This answer will definitely make you confused. At the beginning, everyone thinks that the world is made up of atoms. Because of the scientists at that time trying to break atoms by various means, it turned out that it could not be broken. Until 1897, Englishman Thomson discovered electrons. Immediately after Rutherford, he discovered the nucleus. That's when I found out atoms are not solid. If you magnify atoms into a stadium, so big nuclei, it is only equivalent to a grain of rice in the center of the field. And what about electronics? Fly around in the stands a few hundred meters away. The middle is all empty. In other words, atoms are 99.9999% empty. The so-called hard objects you touch, it's essentially a ball of air. Then we can only continue to demolish it. Afterward, scientists have discovered that there are protons and neutrons in the nucleus. Later, it was discovered that there are quarks in protons and neutrons. Each layer is disassembled. Physicists were excited. Now, physicists use large hadron pairs to hit each other, this kind of super martial arts, to study these small points. Simply put, it is to make particles collide with each other at a speed close to the speed of light. After hitting it, look at the debris. If a particle is still dotted after being hit, nothing leaked out of it. For the time being, it is considered the most basic particle. But note that this is only temporary. Maybe one day the energy of the collision will be higher. It can also hit something new. These elementary particles, according to the current understanding, they have no size. Just a point in mathematics. Just a concept. An existence that could no longer be simplified. Some physicists even think the word particle is not very accurate. They felt that these things were not particles at all. It is a manifestation of the energy field, like waves on the water, essentially just a way of movement of water. Maybe we will find out in the end. There are simply no smallest particles in the universe. Only the energy is dancing there. Sometimes it looks like particles. Sometimes it looks like a wave. Now let's get to the point. So far, physicists consider the most basic particles. There are two major families, quarks and leptons. Let's talk about the quark family first. Quarks are the basic units that make up protons and neutrons. In other words, that is, the basic units that make up the nucleus. Physicists have discovered 6 types of quarks. But in these 6 types, it really makes up these ordinary substances around us. There are only 2, upper and lower quarks. The other 4 are air varieties. Only in ultra-high energy environments will appear briefly. For example, in a particle collider or inside a neutron star. The most bizarre feature of quarks is you will never see a single quark dangling outside. They had to show up in groups. There will definitely be no dispersion. 2 or 3 quarks, held together by a force called strong interaction. How strong is this? so strong that the more you want to separate them, the tighter they stick. What's even more amazing, if you really put in enough energy, want to tear them apart, these energies will directly turn into new quark teams. It's like you want to break up a pair of CPS. The result is a new CP. It's hard to guard against. It is the glue that holds quarks together. The name glue is very vivid. The English name is glue. It means glue. They are the transmitters of force. It is a super universal glue in the universe. Quarks also have a very confusing property. It's called color matching, but it has nothing to do with color. It is the name given by physicists for ease of understanding. Quarks come in 3 colors: red, green, and blue. But this color is invisible to you. Purely mathematical concepts. It's like giving an employee a number. It's just that physicists are a little more romantic. Names are used instead of numbers. After talking about quarks, let's take a look at the Qingxi family. The light word of lepton is very appropriate, because they are indeed much lighter than quarks, and it does not participate in strong interactions. The most famous of the lepton is electrons. Everyone is familiar with electronics. Without it, there is no chemistry. There is no current. I don't have this phone in your hand. Electrons revolve around the nucleus, assemble atoms into molecules. Molecules assemble into everything in the world. Electron also has 2 brothers, Miaozi and Diao Qingzi. These 2 goods are not very stable. The countdown begins as soon as you are born, each a case within a few microseconds. So in everyday life, we can't touch them at all. Each parent and child is also matched with a neutrino. Neutrinos are simply ghost particles. They hardly react to anything. At this moment, there are hundreds of billions of neutrinos from the sun. It's moving through your body, but you don't feel them at all. It's like there is no one. Walk freely through the earth. Come in from one end, get out from the other end. I don't even know how to say hello. Physicists thought at first they have no quality at all. Later I found out that there was still a little bit. But this little bit is really very small, negligible. Quarks and leptons are the alphabet of the universe. Quarks make up the nucleus, a heavy weight. The electrons in leptons make up the outer layer of the atom. The 2 work together. All the elements on the periodic table are spelled out, and then spelled out the whole world. Miraculously, up to now, we didn't find out quarks and leptons have any internal structure. Hit them with the highest energy. They are still dotted. So the consensus now is, they are elementary particles. It is the basic substance that makes up our world. But physicists don't throw in the towel easily. The uranium theory has already been proposed. Gas quarks and leptons. It may still be made up of smaller things. It's just that the current technology can't detect it yet. After talking about the particles that make up matter, there is also a special class of particles. Particles that transmit force. There are 4 basic forces in the universe: gravity and electromagnetism, strong and weak. The first 3 are more familiar to everyone. The last weak force sounds weak qishen, but in fact, he is responsible for certain decay processes of the nucleus. Without him, the sun would not shine. All 4 forces require particles to transmit. It's like you want to send a message to a friend. There must be someone running errands. In the quantum world, these errands are the transmission particles of force. The most famous transfer particle is the photon. The photon is the light itself. It is the transmitter of electromagnetic force. The light emitted by the screen of a solar flashlight. It's all countless photons in motion. Photons have several very extreme characteristics. First, it has no quality. Second, it always on the move. Photons are not stationary. Once it is still, it does not exist. Third, its speed is always the speed of light. 300,000 kilometers per second. Thunder can't be moved. Because of these characteristics, photons actually have no concept of size. You can't say how big a photon is, because it is always moving at the speed of light. In its own frame of reference, time stands still. Space is contracted. Photons can fly in space for billions of years without decaying. Those lights from distant galaxies, after a long journey to Earth, is received by our eyes. These photons may be older than Earth's age. They are like surging messengers. It is always transmitting the message of the universe. Then let's talk about glue. The gluon transmits strength. Glue quarks together. Mentioned earlier, glue is super strong glue, but it has a character. Can't leave your job. Photons can fly freely in space, but glue doesn't work. They are trapped inside protons and neutrons forever. Once you can't get out, try to separate the quarks. The gluon will be desperately pulled back, the tighter it gets. Here's why. We will never see individual quarks, because glue does not allow. Gluon also has no mass. It is also dotted. It can no longer be broken down. From a minimalist point of view, photons and gluons, probably closer to the definition of minimal than quarks, because they don't have an internal structure, not even quality. It is purely the quantum of energy. It is the embodiment of power. There are also W and Z wave subcons responsible for weak forces. And the hypothetical graviton. The graviton has not been discovered so far, but theoretically it should exist, responsible for transmitting gravity. These transfer particles are collectively called wave protons. They are different from quark leptons, which make up matter. If quark leptons are the bricks for building houses, that wave color is cement bricks, heads glued together. There is no boson. The universe is just a pile of loose sand. Interestingly, there is a view in modern physics that the so-called particles simply do not exist. The only thing that really exists is the field. Electrons are the excitation of an electron field. Photons are the excitation of electromagnetic fields. Quarks are the excitation of the quark field. All particles are just vibrational patterns of the field. Think about it this way. Photons and gluons are force-conducting particles. It may be the closest thing to the essence. They are not material. It is the embodiment of the connection between matter. Every time, physicists feel like they are nearing the end. Someone will always ask, is there a deeper layer? This is certainly not unfounded. History has proven time and time again. Every endpoint is just a new beginning. Atoms are not the end. The nucleus is not. Neither are protons or neutrons. Will quarks be? Some theoretical physicists have proposed the concept of money. Follow this idea. Quarks and leptons. It may still be made up of something more basic. Just like protons are made up of quarks. Quarks can also be made up of money. If so, that's simply matryoshka dolls and nesting dolls. There is never an end. But so far, Large Hadron Collider, not yet discovered. Evidence that any quark has an internal structure. Scientists accelerated protons to close to the speed of light. Let them collide. The energy generated, enough to detect a scale of -10 to the power of 19. On this scale, quarks are still dotted. No internal parts are visible. If quarks really still have internal structures, then this structure must be as small as -21 to the power of 10. Even smaller. How small is that? Let's put it this way. If you magnify protons to the size of the Earth, then on this scale, what we are looking for It is tens of thousands of times smaller than a grain of sand. On such a small scale, space and time, the concepts between these two are becoming blurred. Quantum fluctuations can become very drastic. Particles and antiparticles are constantly produced and annihilated out of thin air. The vacuum tumbles like boiling water. Study particle structure in such an environment. It's like counting raindrops in the eye of a typhoon. The difficulty can be imagined. There are also physicists who take a different path. They think that maybe they shouldn't continue to drill into the small. Instead, we should change our thinking. Could it be that there is no such thing as the smallest particle? According to the view of quantum field theory, a particle is just an excited state of the field. Like ripples on the water, ripples are not water. It is the state of motion of water. Then more basic than particles may be the field itself, or the structure of space. String theory is a representative of this idea. String theory argues all particles are tiny, vibration of the strings in different modes. Just like guitar strings vibrate to produce different notes, the vibration of the cosmic strings gives rise to different particles. In this theory, no particles, only vibrating strings. There is another theory called circle quantum gravity. He argued that spacetime itself is quantized. It is composed of tiny spacetime quanta. It's like a screen is made up of pixels. These spacetime quanta are as small as -35 to the power of 10. It's called Planck length. On this scale, spacetime is no longer continuous, but discrete, the kind like Lego bricks. If these theories are correct, the question of the smallest particle itself is a wrong question. Because it is small enough, the concept of particles is no longer valid. Instead, something more basic, excitation of string spacetime quantum fields, and so on. The problem is, these theories are still only mathematical speculation. There is no experimental evidence to verify the energy they need, far beyond the existing technological capabilities of mankind. Speaking of which, we have to talk about the dilemma of experimental physics. There is an iron law for studying the microcosm. The smaller you want to see, you have to use the higher energy to hit. It's like you want to see the details of something. You have to use stronger light to illuminate it. But in the quantum world, light is also a particle, and the higher the energy, the greater the interference to the observed object. Large Hadron Collider. It is the most powerful microscope currently built by man. It has a circumference of 27 kilometers. Accelerate protons to 99.9999991% of the speed of light. Then let them collide. The energy generated by the collision, it can reach 14 trillion electron volts. Such a high energy can already see quarks. But that's not enough. If you want to detect the precursor, or the spatio-temporal structure of Planck's scale, the energy required is millions of times more than it is now, even hundreds of millions of times. To reach this energy level, the collider must be the size of the solar system. This is obviously unrealistic. And even if such a big collider is really built, there are other questions. When the energy is high to a certain extent, energy density from particle collisions, how big will it be? Large enough to form a miniature black hole. In this case, it's not about studying particles. Instead, they are studying black holes. The Heisenberg uncertainty principle is also a roadblock. This principle says, the more you want to determine the position of the particles, the less certain its momentum. Vice versa. When you try to put a particle, when positioned in an extremely small range, its momentum uncertainty can become extremely high, large enough to create new particles. Yes, it made a mess of the whole experiment. Another issue is the ratio of signal to noise. In the Large Hadron Collider, Hundreds of millions of collisions occur every second. But there are really interesting new physical events. There may only be a few. How to start from mass? Those golden signals are found in the data. This requires supercomputer analysis, requires complex algorithmic filtering. It requires the cooperation of physicists around the world to verify it. In 2012, the de Higgs bosons were discovered. It took several years of data analysis to confirm. So, physicists are now facing more than just technical problems. It is a fundamental limitation. Maybe our physics today lack这本 sense. It can never be made. Colliders that can directly observe Planck-scale colliders. But this does not mean the end of physics. Human intelligence is never more than one way to play. Some physicists. The study of the early state at the cosmic level. At that time, the energy density of the universe was extremely high. The whole universe is a natural supercollider. By observing the cosmic microwave background radiation, maybe we can find clues to quantum gravity. Some people study gravitational waves. These ripples of time and space. It may carry the inside of a black hole, or extreme physical information when neutron stars collide. There are also people studying dark matter and dark energy. These are things that cannot be seen or touched. The sum accounts for 95% of the mass energy of the universe. If you can figure out what they are, it could append our entire understanding of matter. Maybe a breakthrough in the future. It won't come from a larger collider. It will come from a completely new theoretical framework, from the pair of quantum mechanics and the re-understanding of general relativity, from a direction that is not yet imagined. Now let's go back to the very beginning. What exactly is the smallest particle in the universe? If you want a straightforward answer, that's quark. Leptrons, photons, gluons, and other elementary particles. They have no internal structure. It can no longer be broken down. It is the most basic existence known so far. But this answer may not be the end. The history of physics. Each answer raises new questions. Maybe one day, we will find that quarks can still be dismantled. You may find that particles are not the most basic at all. It's a string or something else. More likely, we will find the smallest particles. This question itself is a wrong question. On a sufficiently deep level, the universe may not be made up of things. Instead, it is composed of relational symmetry information. Matter is not a substance. It is a way of movement of the energy field. It is the solution in the mathematical equation. It is a surge of probabilistic waves. This sounds metaphysical, but this is the current research status of modern physics. We used to think the world is real and certain. It can be subdivided indefinitely. Now we know the world is probabilistic, uncertain. It may not be possible to subdivide it at a certain scale. This cognitive shift, it is deeper than discovering any specific example. It tells us the universe is more amazing than we think. It is also more mysterious. Maybe one day, humans will thoroughly understand the nature of matter, will crack the ultimate code of the universe. But before that day comes, the question of what this smallest particle is will continue to inspire generations of physicists. Continue running through the tunnel of the particle collider. Write the equation on the blackboard, looking for the glimmer of truth in the laboratory late at night. And we ordinary people just look up at the stars once in a while. Think about every speck of dust under your feet. It's all made up of those incredible little things. It's shocking enough. After all, it is possible to ask such a question, be able to get a little closer to the answer. It is the universe itself. Give us this kind of intelligent life. The biggest gift